Hello everyone. In this video and a few more videos, I'm going to talk about basics of Microsoft Excel. Now I know that I've taught MATLAB in a separate playlist, and personally I'm really a fan of MATLAB. I would rather do everything in MATLAB, but as you know, MATLAB is quite more expensive than Microsoft Excel, right? And when you go out and work in industry, not all of them are major industries with a lot of budget and they can buy for you all sorts of software regardless of their price. So based on the experience from many of my colleagues who have worked in industry and now they are teaching engineering, they believe that Excel is one of the foremost and most used, basically, software in many engineering companies. And of course, MATLAB is way newer compared to Excel, although MATLAB has been around for several decades. But still, because it's more expensive and it needs more knowledge about programming, not everybody knows how to work with it, and not every company is willing to pay for that to get their job done. So I believe that our students in engineering, they need to know this important tool, Microsoft Excel, well before they graduate. And as far as I know, there is no formal training on Microsoft Excel at the university level for sure, and in high school some of them learn something about Excel, some of them don't. But I have found in many of my programming classes that my students cannot even create a very simple Excel worksheet or insert an equation or do something very basic. So I decided that I'll go over a bunch of different topics in Microsoft Excel and I teach them to you. So while you know an advanced programming environment and language like MATLAB, I also want you to know some of the I cannot say simpler, but the most used, probably cheaper options like Microsoft Excel. Okay, so there are a bunch of topics. Right now, I'm going to work on equations, referencing, and comments. And then I'm gonna show you lots of other topics like empty cells, duplicates, sorting, transposing, changing the decimals for precision, autofill, column width, data validation, highlighting, merging, border, color, picture, hyperlink, export to PDF, functions, plots, arrays, matrices, lookup, logic, string, text to speech, document templates, hiding and protecting data, checkboxes, analysis tool pack add-in for statistical analysis, and finally intro to macros and Visual Basic VBA. So there are going to be several videos of me talking about these topics, and so let's get started with some very basic thing here. Okay, so first thing first, let's say here I have this empty sheet. So Microsoft Excel, each document you make is called a workbook, and the extension of the file, as you know, is XSLX. That's the normal Excel file, and each workbook has a bunch of pages. We call them sheets, and each sheet can be completely the data you enter to it can be completely independent from the rest of the sheet. So each one of them is independent. Of course, you can connect them together, but this is very good for data entry and even some basic analysis. So when you open Microsoft Excel, you can go down here and click on this guy, new sheet, and get yourself a new sheet like that. and then you can click in any of these cells and just type in whatever you want. Okay, so let's say I wanted to create these X data from 0 to 10. So what I did is I typed the name of the data, and then I said, well, 0, right, and then move down 1, 2, 3, and so on and so forth, all the way to 10. Now, when this data, especially when this data, they follow a specific pattern, I mean the difference between each two subsequent data is constant, so that's what we call arithmetic progression, then instead of typing from the beginning all the way to the end, and sometimes, you know, you need tons and tons of data. Let's say you want to go from 0 to 50. Well, then yes, you have to keep typing 4, 5, 6, and it takes a good amount of time out of you to do that. So another thing you can do is to use this autofill and select those cells that follow a pattern like that, okay? So I selected these, and Excel is trying to find the pattern. It clearly sees that each time you have added 1 to each data to get the next one. So now you have this analysis, and if you grab this small green square at the bottom right corner of these cells, it tries to find, as I said, the relation between them. So if you drag this guy down, it tries to fill in the blanks and gives you the rest of the terms in what we call like a series or so, right? So you see here, it is filling for me 13, 14, 15, and I can go all the way down, just drag down to what? To 50. So I'm not going to type all of these numbers, you see? I just use the autofill. Okay, so this is a way to get this data created very fast. But you have to pay attention that it works very nicely when you have this arithmetic progression. So again, the difference between each data and the previous one is a fixed number. So maybe you don't want 1, you want like 3. So 0, 3, right? And then 6. And now if I take it, look, each time it goes up by an increment of 3. So it finds it, right? But if it's not a geometric, an arithmetic progression, it's a geometric one. So each term is the previous one multiplied by a fixed number, not added by a fixed number. Let's see if Excel is that smart. So you say, well, my X is, my first data is 1, the next one is 4, the next one is 16. You see, I'm multiplying by 4, I'm not adding a fixed number, because clearly you see the difference here is 3, now here is 12. Now whether Excel can do this, look. You see, now it went from 16 to 22, which clearly is not 4 times 16. And then from 22 gone to 29 and a half, and then 37. So the differences are definitely not what you wanted, right? Here you have 3, here you have 12, then you went to 6, then you went to what, 7 and a half, and then I assume, well, let's see, this is 7 and a half again. So you see, it's confused. Excel have no idea what you're doing, because it is not set for, by default, it's not set really for arithmetic progression. So if I select these and then I click on this analysis, right, then even this one is not going to give me anything, okay? So I can do color scaling and so on and so forth, but it's not going to give me anything like geometric progression, okay? So if you want something like that, then this one goes 64 and so on. You have to create a formula. And I tell you, it's not so hard. I'll show you how to create a formula. Okay, so all you need is to say this cell is 4 times the previous cell, this cell is 4 times the previous one, and then keep dragging it down. So let me show you first very fast, and then we go back and talk more about equations. But let's say here, instead of me typing the number, I say this cell is equal to, or I insert an equation for it. It is 4 times the previous cell. Now, each cell in Excel is given by a column and a row. So this cell is G and row 4, so it's G3. the one I clicked on is G4. So I'm saying G4 is 4 times G3, right? And then I enter. You see? Now, if I drag this down 1 unit, what happens? So did you see what I did? I click on this cell for which I typed in an equation, and then I drag it down. Then it tries to repeat the same equation I did, which was G4 was 4 times G3. It tries to apply that now to G5. So now G5 is going to be what? It is going to be 4 times G4. If I drag it one more down, now G6 is going to be 4 times G4, and then I can keep going down, right? So by an equation, I could resolve the problem. I could relate each cell to the previous cell. Now, this way of referring is called relative referencing. What does that mean? It means when I inserted a formula here for cell G4 based on G3, when I try to extend it to the bottom cells, the same relation will update itself. So again, listen, I did this. G4 was equal to 4 times G3. When I go to the bottom cell, it updates the row number of these G's by 1. So this guy becomes G4 equals 4 times G4. And then G6 becomes what? 4 times G5. So you see, the position between G3 and G4 is 1 row difference. So when I extend it to a new cell, again, the difference between these should be 1 row, 4 and 5. Again, 5 and 6. So the relative position between 3 and 4, 4 and 5, 5 and 6, they are the same, so we call it relative referencing. Okay? Each cell here is related, or it's given relative to its the cell above it. Okay? Now sometimes you do not want this. Sometimes you want to keep this cell G3 fixed. Or maybe this 4, this number 4, here I typed it, maybe you want it to come from here. Maybe this number that I'm using in each one of these equations, and it's fixed, if I say 5 for that, you see I typed this number 5 in cell I3, right? If instead, take a look here what happens. If instead of saying this number is equal to 4 times G3, I say this number is equal to this I3 times G3, right? 5 times 1. Well, no problem. Look, here I get 5. But look what happens when I try to extend it to the bottom one. What do you expect to happen? So here what I had was, again, G4 was I number 3 times G number 3. So I expect when I go down by 1 cell, it becomes G5 equals I3 times G4. But it doesn't, because 3, both of these 3's, their index will be updated. The row position will be updated. So I'm not going to go from 1 to 5 and then to 25. Look, I'm going to go down to 0. Why? Because if you look at this cell, the equation for it is what? G5 is I4 times G4. Okay? The relative position between 3 and 4 for all of them is 1, so now they're all incremented by 1, so this is G5, I4, and G4. And guess what? You don't have anything in I4. And when you don't have anything in I4, the default of Excel is it fill it by a 0 for you in this formula. So it considers this blank cell as a 0, and boom, you get a 0. So you see here, what you really want is, I want the relative position between G's to stay the same. So the index for G's go up one at a time, but not for I. I want the I index to not be relative. I want this I3 to be what? Constant all over these cells. So I want this. You see, the G indexes are going up. The relative between them is 1. But I don't want I3 index to change. I want it to all the time stay at I3. So I3, referring to I3 for which the row index does not change, we call that referencing to I3 absolute referencing. Okay, so that's called absolute referencing. I don't want this I3 to change. This 3, I want it to be same, but the G's, I want them to change. How can I achieve that? Well, what you need is this. If you want that to happen, so the location of that I3 does not change as you extend it down, what you need is to use two dollar signs, $1 before I and $1 before 3. Whenever you specify any cell by the two dollar signs, one before row index, one before column index, that location of the cell will be absolute. It's not going to be updated. Look, here is this 5, right? But now if I extend it, you see, that's exactly what I want. If you look at the formula for it now, you see, still I3 times G4. Look, this is still I3 times G5, I3 times G3, right? And so on and so forth. So double dollar sign means what? Means absolute referencing. If you don't have it, then it is going to be relative referencing. Okay, so this is absolute versus relative, which is a very important topic. Okay, and this is one of the first things that you want to learn in Excel. Now, let me show you here something. So here I have created this X data from 0 to 10. I have two numbers here. One of them is the slope of the line, one of them is the y-intercept. And then I want to create the data for the line y equal ax plus b, correct? Where x coming from this column in B, and this a and b, the slope and y-intercept, they coming from D2 and E2. So look, the way I created this formula is this. All I did was I clicked here in this cell and say this is equal to this D2 times x plus this E2. But you know that this is fine, but if I go down here and try to extend this formula, right, I'm gonna get a bunch of zeros because now it is trying to get the values of slope and intercept from what? D3, E3, D4, E4, and so on. I'm doing relative here, but I don't want relative. The only thing relative I want are the B columns. D and E should be absolute, so I have to modify my formula by what? By the dollar signs, right? D and E, you should not change. So I make it absolute, and now look, when I go down, it's perfect, right? This, as you can see in all of these formulas, E2 and D2 are not going to change, okay? And then I can do a plot of that, right? This blue line here is the plot of y versus x. We're going to have a separate video on how to create these plots, okay? So my goal here is not to do the plots. Or let's say here, I want to create the plot of a general harmonic function where A is the amplitude, omega or W is the frequency, C is the phase, and B is the bias. So here, again, the X data is coming from column B, but these coefficients A, W, C, and B, I want them to come from not cells in this sheet. I want them to come from another sheet. That's where you can link different sheets together. Okay, remember what I told you? These sheets, by the way, if you don't want any sheet, you can just right click on it and what? Say delete. So I want those data to come from sheet number 2. So that's right now I'm trying to link this sheet with this name to sheet number 2. I want to read this data from sheet 2 and then plug them into the formulas for formula for A, W, C, and B. So how can I use the values in cells in another sheet? That's where you have to use the exclamation mark. So look here, the way I did it is, let's say the first number is amplitude A, right? And amplitude is coming from where? It is coming from cell what? C2, but in what sheet? In sheet number 2. C2 in sheet 2. So look how I'm referring to it. Look at here. Sheet 2, exclamation mark, and then cell C2. And you see, for cell C2, I have used $sign. So when I drag this down, then it doesn't go to what? C3, C4, C5 in that sheet. So that location has to be absolute. And since it's from a different sheet, I type the name of that sheet, whatever the name I named it, and then I use what? I use the exclamation mark. It means that cell belonging to that sheet. And then times sign of, there is the built-in function in Excel called sign, for which the input is in radians. So here it is treating these x values as radians, not degrees. And then again, you see sheet 2 D2 times B2. So sheet 2 D2 means what? Means the frequency times B2. Now that B2 does not have any sheet in it. So they are coming from B2 of this sheet. Plus again, sheet 2 E2 and then sheet 2 F2. So then you add the phase and the bias to it. So you see everything here is coming from sheet 2 except for the values in column B2, and they are not absolute, they are relative. So once I insert this formula, then I can get my data from another sheet. That's how you link them together, okay? And once you get this data, again, for the first value, you drag it down all the way to the last value. And again, here I'm plotting this Z data versus X data in red. And again, you see here I have added X label. If I want, I can add Y label. I can do legend. Again, in a separate video, I'm going to go over how to do the plus. I just wanted to tell you how to read data from another sheet, okay? So I told you these two topics. I told you how to insert an equation. And let me tell you one more thing that is important. So sometimes you create a formula for one column, right? And then another column, you relate it to this column that it is a function of something else. So it's going to be like a function of function. Can you do that? Sure. So let's say here, x is, just type in some numbers again, 0, 1, 2, right? And then drag it all the way to as much as I want. So here, highlight these and then drag this down maybe to 10. Here, y, I want it to be like w times x plus theta. So the way I define this function, I first create this argument inside the sign as a variable, and then a times sign of that variable plus b, I make it another variable. It should give me the same data. So I'm treating this as a function of function. Okay, so here, this y, say this is equal to w times x plus the phase. Now pay attention, I don't want the location of D2 and E2 to change, so I have to make them absolute referencing. The only thing I want to change are the I columns. Right? So I get this y and then I drag it down. So this y here is w times x plus whatever we called it here, c, where c is the theta. Okay, now I want this z to be what? A times sine of now this y plus b, where a is the amplitude, b is the bias, and y are coming from this column. So now I say this is equal to this cell times sine of, by the way, whenever you type in any function, MATLAB, I'm sorry, Excel, I've been teaching MATLAB so far, I keep mixing them. Excel will give you a suggestion for any function it has that starts with those letters. So you can double click on it, and then it says the syntax for it. You have to type in a number, and it's a sign function, it's a number. If you click on them, it brings help for that. Okay, so if you want to know how to deal with that function, then you see it says the number should be what? In radians. Okay, so it's always a good idea if you don't know how to use a function or you don't know the syntax for it, always go ahead and click on that function so you have more information about it. So it's sine of what? It is sine of this number and then plus the bias, which is this number. And again, pay attention, I don't want the location of C2 and G2 to change, so I'm gonna make the referencing to them absolute, like that. And then I'm gonna drag it down. Now, if you look at this 1.86 negative 53, okay? Now, it seems like I did not get the same numbers, did I? Right? Because again, you look, it's C, D, E, and F. And here I used D and E, and then I use what? C and O. I see why. The reason is I use this second theta, not the bias. That's why. So let me get rid of this. And in that equation, I use G, not F. So here, this thing should be G. And update it. Good. So now if you look at the numbers, 1.86, negative 0.5, that's the same as these numbers, and it should be. Okay, so clearly no worries. You can do a function of function. One column could be the function of another column, while that column itself is the function of something else. That's fine. Now, let's talk about updating it. So here, if I update one of these data, does it update the corresponding thing? So for example, maybe this 2, I want it to be 2.5. You see, immediately the numbers that were depending, related to that 3, which were these two guys, right? In J and K11, they change immediately, they get updated. Okay, so once you change some value, then as long as it's relative referencing, anything that is related to that relative referencing is going to change. But you might say, well, what if I change this absolute referencing value, 6? Let's change this 6 to, let's say, 8. If I do that, then all of this J column and K column should change, right? Because when you change W, J column changes, and since K is a function of J, the whole K should change. Now, is that going to happen if I change this 6 to 8? Do I get update on both columns? Let's see. So I say 8 and enter. And boom, yes, I got everything updated. Okay, so that is important. When I change the value of a parameter, the whole thing does change. Okay? Now, so you saw whether I do absolute or relative referencing, if I change the value of that cell, everything related to that will be updated. The only exception was, as you just saw it, when here in this formula that I entered here, I change the cell location, not the value of the cell location. Remember, this one was F2, so I had some number here, whatever it was, correct? I had some F value here, let's say 0.56. And in that formula, I had F instead of G. Look, when I change it to F2, right? Let's look at it again. So this is using G2, right? This is what I had with G2. Now, take a look again. If instead of G2, I change it to F2, so I'm changing my reference cell, not the value of it is changed. When I update that in this cell, in the formula for this cell, is that gonna update the rest of them? Look, I enter, but you see the rest of them have not been updated. Only the first one does. And so now because the formula for this first cell updated, but not the rest of them still with G2. But if I, again, apply this dragging, so I grab this corner and drag it all the way down, now all of the formulas will be updated as well. Okay, so now you can see that. They're all now F. Okay, so please pay attention to the difference. Updating the value versus updating the location. Okay, that's something different. So here I updated the value, the location from G to F. And again, if I enter, nothing is gonna change for the rest of them, okay? Unless I do it like this, then yes, all of the formulas will change. Okay, so that is about what? Equations, creating equations. And to create these equations, we have tons of functions. In a separate video, I am going to show you lots and lots of functions that exist in Excel, and I'll show you how to use them. But again, as long as you know how to do equations and do proper referencing, then you should be good for creating any data that you want. One more thing that I wanted to talk about before finishing this video was comments. Well, yes, just like MATLAB or any other programming language, here in Excel, you can also add a comment for other people to see, and probably even they add their own comments. So let's say I want to say, hey, this is the slope, and I got it from some experiments. I'm not so sure about it, right? Or this is the y-intercept. I just want to provide some info about these numbers. So all I need to do is I click on that cell, right click on that, and say what? Insert a comment. So slope needs to be rechecked. I'm not sure about it, right? Or this one, I right click and say what? Y-intercept value is fine. Okay, and then anytime anybody opens this and look at it, the people who I shared this with, on the cells that there is a comment, you're gonna see a small red triangle at the bottom right corner of that cell, and if you move it, it's gonna show that comment, and it's gonna show who made that comment. Okay, so just wanted you to know about it. Okay, thank you so much. See you in the next video.